Now let's take a look at the vision side of things and see how Captum can help us analyze how images are being classified and what contributing factors are used in the decision for classification. To help us with this, I created a simple animal classifier. So this classifier is fairly simple. It just classifies whether a given picture is a cat or a dog. And based on that picture, it's going to give us a classification plus a probability. As you can see here, I have a cat.jpg and a dog.jpg. And if we take these two images and pass them through our model, we'll see what the classification should come up with. Based on our classifier, we can definitely see that the images have been classified correctly. The dog.jpg has been classified as dog with 100% probability, and the cat.jpg has been classified as a cat with 100% probability. It turns out image is one of the more difficult things to quantify in order to determine how classification happens with these machine learning models. Thankfully, we have a bunch of tools that Captum provides in order to make this much easier to understand. And it's even better, since that we're talking about vision, that these tools are designed in such a way to provide us graphical representations so that we can help understand what is going on. So if we're going to use Captum in order to understand how this classification is happening, I'm going to use the dog.jpg as an example to pass through this model in order to understand how things work. So let's go ahead and pass the dog.jpg through our classifier. As you can see here, the dog image is being correctly classified, and we're creating 3 different images in order to help us better understand how this is happening. We have the dog_noise.png, we have the dog positive attribute.png, and the dog_lrp.png. So let's go ahead and take a look to understand what these images are all about. So this is an image representing the positive attribution for the dog.jpg image. This image represents the gradient-based attribution for the positive classification for a dog. Gradient-based attribution methods compute derivatives of the model's output with respect to the input pixels. By doing so, they essentially answer the question, how sensitive is the output to small changes in each pixel? So in non-technical terms, another way to look at it is, imagine you're tasting different ingredients in a dish. You slightly change the amount of each ingredient and notice how much the overall taste changes. This is what gradient-based attribution is all about. Next, we move up the stack with the available tools in our toolkit. Integrated gradients address some of the shortcomings of raw gradients by accumulating gradients along the path from a baseline to the actual input. You can see here from the image that the image gradient has a stronger representation or mapping to the original image on the left-hand side. So in non-technical terms, imagine you're deciding which part of the story convinced you to try the restaurant dish. Instead of just recalling one moment, you remember the entire build-up from when you first saw the menu to when you first tasted the dish. That is what integrated gradients is all about. It's about taking the collective input or experience in order to draw a conclusion for classification. Further moving up the stack, we have layer-wise relevance propagation, or LRP. So LRP takes a different approach. Instead of focus solely on gradients, LRP backpropagates a relevance score from the output layer down through the network, distributing the output predictions credit to each neuron, and eventually to the input pixels. So another way to think about it in a non-technical analogy, think of it as retracing your steps to understand why you made a decision. Imagine you ordered a dish and then trace back through the conversation with the waiter, the description on the menu, and even the restaurant's ambiance. So think of this as walking backwards. And if you take a look at the picture on the right, that has a far more accurate representation for the image provided on the left. This is yet another way to understand how the classification for image works in Captum.